Now strain is simple. Strain means change in dimension upon original dimension. So change in dimension. What do you mean by dimension? Dimension of an object is not that dimension MLT, it is the dimension in terms of length, breadth and height. Okay, so this is change in dimension upon original dimension. So what do you think? What type of strains I can write depending on this basic formula, change in dimension upon original dimension? Let's say first one is longitudinal. Okay, so in longitudinal strain, as the name suggests, it is what? It is the change in length upon original length. That means we had this, we were talking about that wire, okay, below which a huge weight was suspended, due to which the wire got elongated by some length. So original length, suppose this was the wire, this much was the length of the wire with some weight. After the removal of this thing, we saw that this thing got reached here, like this was the final thing. So this is the increase in length and this is the original length. So that is called longitudinal strain. Another one would be volumetric strain. What is volumetric strain? Change in volume over original volume. This is simple. Last one is shearing strain. Now shearing or tangential, this is also called tangential strain. Shearing strain means, now you'll have to try to understand this concept, what it means. See, suppose I have this cube where the base is fixed. The lower part of the base, this cube is fixed now, okay, and this whole cube is subjected to a force F, which is acting only on the upper surface of the body, due to which what happens? This surface gets displaced. So this thing reaches here, this thing reaches here, we have this thing, and similarly, or you can say just this much angle, instead of this whole I'll be drawing only this much angle, and similarly this thing, this got displaced here till here and here. Okay, so this is the diagram we are looking forward for. This thing has reached here and this thing has reached here. So from the diagram what you can see, only the upper surface got displaced whereas the lower one was fixed. So there is a small angle created here. So this is what shearing stress is. It is the small angle by which the upper surface normal to the fixed surface moves when the upper surface of the body is subjected to a tangential force, right? So you know from the basic property of mass and trigonometry that when theta is small, then tan theta tends to theta. That means, what is tan theta? This is height upon base. According to this theta, this would be height and base. So this is called delta L and this is called L. So this thing also is delta L upon L. Now don't get confused with the formula of longitudinal and shearing. The formula looks similar in notations, but otherwise they are absolutely different. In longitudinal, this is change in length upon original length, whereas in shearing, it is the angle by which the upper surface moves above the lower surface, and it is the small distance which it creates, right? The small distance by which the upper surface has moved upon the total length of the body. So just they are in same notation but completely different meaning and formulation.